Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Tectus TE540 3D175. The factory has their date stamp kind of mucking up our part number, but it's a 540 is this hinge. 3D is the adjustment, and then the 175 stands for the bronze light finish. This is what a box of hinges look like. There are two in a box. They're heavy. They weigh about 5.5 pounds. And this video is going to serve as a overview of the hinge in general. We're going to start with the adjustment because it's certainly the adjustment is what sets this hinge apart from its competitors. The ability to adjust it in 3 dimensions. You can adjust height. You can adjust the door as it sits in the pocket. You can then adjust the positioning of the door inside of the rabbet itself. So after the adjustment, we're going to get into an overview of the system, how to prep a door and a frame for it, guidelines in terms of weight ratings of doors that you'll be able to handle with this. There is going to be some template review that we'll go over. And likely in that overview, we'll talk about different finishes that you can get your hands on, and we'll touch on different models. So the adjustment is, here's the hinge. Okay, all the screws are basically tight on this hinge, meaning there's no adjustment that's been done to it. It's been taken out of the box from the factory, and this is what it looks like. There's a lot of screws here, and you do, in my opinion, at least I needed to, study it a little bit in order to really understand what's happening with all of these several and many screws. The principle of how to adjust this is basically two forces acting against each other. You have to loosen one screw, or set of screws, in order to manipulate a second set and then retighten the first set. Makes kind of sense. If you've got a piece of threaded rod and it's going through a shelf and you've got a nut on either end and you want to move that threaded rod, you got to loosen one nut, tighten the other nut, tighten down that first nut, to move it laterally. Same sort of concept. Admittedly, there's two schools of thought on an adjustable hinge like this. There's two schools of thought. I don't need an adjustable hinge. I know how to mortise my door and frame for this hinge. I don't need, I know how to mortise. I know where I'm going to place things. I can do the math and get everything mortised correctly. And sure, of course, a carpenter, a finish carpenter, a doorman, someone who makes a living doing this stuff, does not need any adjustment at all. The issue is, however, this hinge, in my opinion, meaning the old school person will not use a Tectus, they'll use something else that is the similar concept, but doesn't apply or doesn't find attractive its adjustability. To the other person who says, what are you talking about? Why wouldn't you want the ability to adjust the hinge? In my experience, is that the hinge does, and I've never seen a Tectus hinge after 20 years of use, so I really can't account for, are these bolts going to hold up, to high volume use with the loosening, the tightening. They've been on the market for a very long time. I've not heard of it being a chronic problem, so I've not heard of it being a problem at all. So I'm going to say that it is not a problem. The thing that strikes me as valuable as someone who sells someone a door opening system, and that same client 5 years from now is still my client, 5 years later is still my client, 25 years later is still my client. The ability to adjust gives you the ability to maintain that door in the opening over time. And it's not that the hinge is going to move, even though screws can certainly loosen and move, but it's going to give you the ability to counteract a building settling a little bit, movement of the door and frame, and to be able to keep that door and frame in relationship to itself is an important aspect. The question that really comes up is the long-term ability to adjust the hinge in the long term a side effect of the very design of the hinge? Because you can adjust it initially, does it mean that you have to adjust it long term? If you are working on a hinge that features no adjustability whatsoever, you can't. The question really becomes, as in a standard butt hinge, where there's literal wear and tear on the hinge, where a door that is square, plumb, true, and level when it's installed, a pair of doors, let's say, and now those two doors have moved in and now they're hitting at the top. Well, what's occurred? The doors probably haven't swollen in size. They haven't gotten bigger. That top hinge is fatigued. The ability to mitigate that problem would be nice, adjusting it to bring the door back up. With this sort of hinge, you can certainly do that within a reasonably small margin. It's not a huge amount. But if you're able to move it a 1/16 of an inch on each hinge, well, now you've got an 1/8 of an inch. That is a huge amount. So the adjustment is the first place that we're going to start. The installation instructions, I find, like all European sets of installation instructions, require us to adapt the way that we're accustomed to seeing it. American installation sheets or templates are literally all the data possible, and then you derive from that the information you needed. It's in all instances, it's, you know, unless there's a mistake, all the data is there. The European approach is obviously far more visual, and does require, while I think it's intended to be easier to use, does require study. But once you study it, like a template, if you're going to install a hinge or a pivot, let's say, from an American manufacturer, you do need to learn what clutter to cut out, what information does not apply. They're not bombarding you with information in this material at all. So let's start with the document called Fitting Instructions, and all these links are below this video. So fitting instructions is where we'll start. It's a 2-page document. The adjustment is on the second page and occurs, and we're going to focus on the second page, occurs in 3 different areas: height adjustment, what they call depth adjustment, and then what they call side adjustment. So the height adjustment, that's pretty easy to certainly to understand, and I'm going to take a hinge and use it as an example to illustrate that. Okay, so I've got a hinge here and I've got some screws loosened up, and the first item is the height adjustment. First, a definition. There is a door leaf. This is the dedicated door leaf. This will only ever go onto the door. Okay. Height adjustment and then lateral adjustment is done on the hinge leaf, on the frame leaf of the hinge. So the way that they illustrate this is when the door is open at 90 degrees, and I'm using a multi-set. This is 4mm, by the way, that you need. I would, if you're doing a project when you have a number of these to adjust after installation, I would invest in a T-handle, 4mm, nice length rubber handle, and I would probably leave that with the whoever's inheriting the project when the installer leaves. So it's always shown in the door open at 90-degree position. Okay, shown like this. We have a lot of screws on the hinge leaf. These 2 outer screws, here and here, those are called the clamping screws. That needs to be loosened in order to get adjustment to occur in height. So we're going to talk about height first. And I have it loosened to where the point that it just simply works. The way that the height adjustment actually does work is I'm looking for what they call Okay, so they call it lower height adjustment screw. And I've removed, you've got an upper and a lower height adjustment screw. This right here, that screw, and this plastic piece that's in there, and I've removed it here. This is what it looks like. It's got a wedge sort of principle to it. Well, so does the hinge portion. Okay, so what happens is that sits in there like this, and as you loosen it, you have the ability for that hinge to now move because you've increased the distance between the two mitered ends. As you loosen the height adjustment screw, you're first going to loosen your clamping screws to permit movement. You're then going to loosen, or I should say, forgive me, you're going to adjust your height adjustment screws that will allow you to make that relationship between these two mitered pieces such that you can move them. As you loosen one and you tighten the other, you can then take that hinge and move it up or down. Once you've got the relationship of the two compounding forces, those two wedges against each other, well, they're really going to be like this. As you have those compounding forces loosened, tightened, loosened, tightened, as you have that relationship set, you will then tighten the clamping screws. You've got to loosen the clamping screws to permit movement of the leaf itself, as I have them loosened. If I tighten them, it wouldn't move. Adjusting the height adjustment screws wouldn't do anything because the clamping screws are tight. So you need to first initially loosen the clamping screws to permit that movement, then make your adjustments. Okay, so what I am driving at is as I tighten my height adjustment screw, I am now going to limit any adjustment that I have here. So what they want you to do is to, according to the installation instructions, work on the, if you need to raise the hinge, you're going to tighten the lower screw because that will drive it up. And if you need to, for some reason, bring it down below, you can work on the top screw. So I've got them both loose, and now they're both going to move. That's just how that works. It would be beneficial to see the hinge leaf itself. And there are reasonably elegant 1-minute videos online from Tectus showing all three adjustments. And those work. I found that it didn't help me understand how the hinge worked, which is the purpose of this video. So I've loosened everything, and I'm going to lift that out of the cavity. And in fact, this needs to come out anyway during your installation. So now we can kind of study how this works. Okay, I pull my height adjustment screw out. You can see I've got that angle there. Let's pull out the clamping screw. You know, it's kind of captured because of the plastic adapter that's there, so I'll just leave it. You can see as I were to, if I were to manipulate that hinge, that screw, the height adjustment screw, that's going to actually draw. And you do that at both ends, you're going to get to a point where you will have the height that you require. You will tighten those, you'll make sure that the two height adjustment screws are where they need to be, and then finish it off by tightening your clamping screws, which will keep everything in place. And that's how the height adjustment portion works. So that's incredibly simple and straightforward. Loosen the clamping screws, make the adjustment on your bottom if you need to move it up. If you need to move it down, you're going to counterclockwise turn it. Get the door set to the position that you want, and be mindful, you're hanging potentially 120 kilograms. I think that's going to relate to 250 or so pounds. So be mindful, you've got a lot of weight on these screws. So proceed cautiously as you make the adjustment. Make your final adjustment. Set your height adjustment screws in place, then tighten your 4 clamping screws. 1, 2, 3, 4. Let's move on to the depth adjustment. I call it lateral adjustment, and let's study that. Now, the next portion we're going to work on is going to be called what they call depth adjustment. And depth adjustment is when the door, and I'm putting the hinge back together from our height adjustment, the depth adjustment is how the door sits in relationship from the face of the frame to the face of the stop. I would call it lateral adjustment, and I'm going to illustrate what that means right now. The lateral adjustment really permits the door to sit correct in the rabbet of the frame. Never would you need to adjust the door in or out that I'm aware of. This hinge permits that. Let's take a look. So the three adjustments. Height, yeah, that's nice to be able to adjust that hinge height-wise. To take the door in the frame and move it this way, that's gold. But then to move it this way as well is what's really interesting. In a quick drawing, if you'll permit me. There's our door. The lateral adjustment allows us to move it in that direction. Okay. Moving it side to side is the third and final adjustment that will allow you to move that door so you can get a tight margin on either side. But to position that door in the depth of the rabbet, this next adjustment will do. This, figuring out how this worked originally did elude me because it wasn't obvious, and it's because the installation instructions don't seem to match the physical hardware in your hand. I'm going to tighten our height dimensions so that we don't get movement that we don't want to otherwise see. Just tighten it so that it doesn't move on us. And again, a T-handle, nice length Allen wrench would be really well worth the investment. This multi-kit here. I don't do a lot with metric, so, you know, I have only what I need to get by, I suppose. So now we're locked in terms of the height. We're not going to move at all in terms of height. Illustrating this, positioned at a 90-degree angle, is how the elegant videos show it from Tectus. You have to loosen the fixing screws. These two screws, loosen those. Loosen these two screws. I may already have them loosened. Yeah, I do. Okay, now what happens is there is a very discreet hole right there between these two screws, right at the top, right at the bottom between these two screws. There is a discrete screw that's in there, and it is shaped like this. As you turn that bolt this way or this way, you are going to move that hinge. Again, you have to loosen the fixing screws in order to move it, but you are going to take your wrench and get it put right into that screw that's there. That 4mm screw is definitely going to, that 4mm wrench is definitely going to allow that to move. As I tighten and loosen, I simply wish to determine the best way to illustrate this. Okay, it needs to get pushed in a little bit. I've got this huge wrench in the way. I'm going to flip that over. Okay. Now, if you are studying this colored block here, the bronze block, as I turn this back and forth, you can really detect the movement. So what that small amount of adjustment is doing is literally moving that in this direction. You want to scooch it in a little bit closer to the stop of the frame, you can. You want to move it out a little bit further, you can. And that's what that dimension is, that's what that set of screws are for. You have to loosen the fixing screws, make your adjustment. So obviously what's happening in the extrusion inside of here it kind of looks like that. Okay. I'm going to take that apart. So I'm going to quickly remove those screws so that we can show you what that looks like. So now I have the 4 fixing screws removed. I can then work this entire hinge assembly out. And you can study what I was attempting to illustrate earlier, and that there are small little tiny teeth right there. You can see them top and bottom. Okay? And as we look at the back of that adjusting screw, that's what allows that to cant in and out, to move that laterally. You really only see it expressed very elegantly when the hinge is at 90, when the door would be at 90 degree. So you can see the movement exaggerated, but that's how that's done. I will, you know, when you put it back together, it does require a little bit of fitting to go back in, a little bit of vibration to get it to sit. I would tell you that I think it is not a bad idea to have that lateral adjustment, because doors can cup and they can bow. They can cup, and that cupping might be somewhat mitigated by a small amount of adjustment. By that lateral positioning. The argument really is going to ultimately always stand for me in terms of what value does the adjustment have? Are we compensating for an installer's possible variance in the exact locations of how things are being machined? Yeah, very likely. Non-adjustable hinges of this sort, I do believe, are intimidating, and they put people in a position of not considering them because of the absolute exactness that's required when machining the door and frame for the material. However, that, like all other things, is a reflection of the skill of the person who's doing it. If you personally can do it, then you personally are fine without adjustment. If you feel that you cannot, look at an adjustable hinge. Now, we've covered the lateral adjustment. The next thing is to talk about how to move that door inside of the frame when it is in the closed position. Your side adjustment is what they call the next step. Side adjustment is, of course, the least complex to understand. Basically, it's these 2 screws that are here and here, and they will literally allow that movement of the door this way to increase or decrease the margin between the edge of the door and the jamb. And simply, as I take my tool and manipulate it here, I'm going to hold it this way so that you can see how that draws itself back and forth. So right there, there's very little margin between the faceplate, or the bronze U-shaped feature, and the edge of the bracket. As I turn it counterclockwise, it will draw it out. You can see it comes out substantially. So the truth of the matter is, lots of adjustment in all axes is how that's going to work. Okay, that covers the adjustment portion of this hinge. Now let us move to a review of the balance of the document called fitting instructions. It's an all-in-one kind of document. The installation instructions that come with the hinge are unreadable as far as I'm concerned, only because the print is just far too small. The document online, we can bring it up. I'm not sure if even 18-year-old eyes would be able to read this very, very well. It's quite small. If it was not written in 4 languages, it'd probably be a one-sheet situation. So, oh my gosh, all this to read? No, it's in 4 languages. So you'll only probably be reading one section of it. It does tell us, in terms of a approach as to how to install the material. And this document is inherently different from the fitting instructions that they give. Yeah, this document is indeed unique, and there will be a scanned copy, and this will be called installation instructions or assembly instructions, because what they do is they do give you, and what's really crucial in all pieces of complex hardware, that you initially start with the laying out of all of the parts to make sure you have everything necessary. So on this page is where we're going to start with making sure we have everything before we start to install stuff, to find out I'm missing screws that are crucial to the installation of this product. Okay, now continuing on with those assembly instructions, we're going to take a look at the parts that they're calling out. And the bottom line is you're going to get certainly enough fasteners. You're going to need a total of 12 of each type of screw, wood screws and machine screws. They have not provided us that. Okay, so they're giving us 12. Part number 1. Let's just take this. Page 1, right side, to the right, the table showing what's included. You're going to get 12 wood screws. You're going to get 4 of the M4 by 10 millimeter. Those screws are going to be the fasteners that are going to allow you to attach the faceplate. You're going to get 12 of these wood screws. Okay. If you are going into a hollow metal frame, you are going to need machine screws. I have done a job, actually a quite large job, maybe 200 Tectus hinges for a rapid transit system in the Middle East. All of the hinges were 3/16 stainless. The manufacturer was made aware of the composition of the door and frame, metal by metal. They did not send screws correctly. They refused to send them at no charge initially. They ultimately yielded, because the Type 316 machine screw, of course, is not just in your local home center. The screw package that you get here is going to work really good if you have a wood door and a wood frame. You're certainly going to want to make clear at the time of order what the composition of the door and frame are. We will pass that information to the manufacturer so that they are going to be able to understand what it is that we need to get the material attached. My argument to the factory was the composition of the door and frame was clearly expressed on the purchase order. The material was not packaged accordingly. Now we have $30,000 or $40,000 worth of hinges that cannot be installed, that we've waited 2 months for because of the high custom nature of the hinges. That was the lead time. That's normal. And because we're missing 300 screws or whatever it was, everyone cannot proceed. So this happens to be a wood door and a wood frame application. I know the client's getting the proper fasteners, but we don't need to ever have that to be a problem. Now these machine screws, you're going to get 4 of them. They're M5 by 20 millimeter. These, and that is a Torx style bit. They don't tell us the Torx drive for this, at least not that I can see. Perhaps we'll discover that. So the hinge comes from the factory for a wood door and a wood frame. That's the standard. Okay, if you are doing a steel frame and a wood door, you then, this is the frame leaf, that's the door leaf, you will then use a total of 2 screws at the top and 2 at the bottom, and that's why you have 4 screws. Those are what will attach directly to your reinforcement that has been done inside of the frame itself. Okay, that covers why those screws are there. If you as an aside, if you happen to be doing a steel door as well, you would, they make what's called a receiver, a reinforcing box that you can use in the construction of your door that will include the machine screws that you require for this. The issue earlier about the 316 hinge project where we were doing for the rapid transit, the manufacturer didn't need receivers. They manufactured the steel doors to receive the hinges. The problem was the screws weren't sent. The manufacturer's position was, you didn't order the receivers. No, because we didn't need them. Okay, but we still have a steel door and a steel frame. After that, you have the 4 small M4 by 10 millimeter, and that is simply going to be used to hold your face plate on. Okay, there's 2 in a package. Oh, okay. Forgive me. I'm looking at why I have 4 packages for 1 hinge. There are 2 hinges in a box, so you are going to need I must have pulled them out from somewhere else. We only need 2 packages per box, and I'm quite sure that I must have pulled them out. And these plates are what is going to allow you to finish off your installation to make it look complete like that. That one little machine screw will go through that hole and tighten it up here. Okay, really nice installation on that. So that covers all of the screws that you have. The good thing about confirming that we have all the screws is now you know you have everything. Moving on further to the tools required, they are showing us that we're going to need a 3 millimeter drill bit, and that's going to be certainly to pre-drill the holes for the screws. You'll absolutely do that so that you don't split the jamb. You'll need that 4 millimeter Allen wrench. You will need a Phillips screwdriver. A number 2 would be fine. Okay. Then you're going to need a 24 millimeter diameter 2-flute carbide router bit. That's going to go when we talk. That we'll discuss that when we talk about the preparation. On pages 2 and 3 of the installation instructions, we certainly get to see the same information delivered. Page 2 and 3, yeah, on page 2 and 3, we're seeing that information delivered for different applications. On page 2, it's for what's called a block frame. A block frame is a term that must be used to express the installation of this hinge to some sort of structural member of the wall, would be my guess. If you're attaching this directly to, of course it has to be some sort of a frame, and looking at their cross-section of what they call a block frame, It is just simply an exceptionally, it would be wood, it wouldn't be steel or aluminum, and it would be an exceptionally thick piece of lumber that will accommodate the sheer depth of the frame itself. I mean, from the rabbet to the back of the hinge itself, it's 35 millimeters, so inch and 3/8 for sure. So you're dealing with a thicker than standard frame, to be sure. That would be your block frame installation, is what they're showing there. So it's a heavy piece of equipment. When you move to, and I just want to discuss the wood casing frame in the same context. The difference between the wood casing frame and the block frame, the wood casing frame appears to be a laminated sort of construction, where your hinge is actually pierced through the back side of the 3/4, the 1x material that's likely built from. So you're either dealing with a solid piece of lumber, block, or you're dealing with a more typical wood frame construction, which would be likely 3/4 or 1x material, 3/4 inch thick. Block and wood casing frame versus steel frame and aluminum frame are different in the sense that they sell this receiver, and that is the mounting box that you would use when prepping your door and frame, your frame, or the Tectus hinge, that they sell separately, that you might consider purchasing. When I order hollow metal doors and frames for these hinges, we don't supply the receiver. The hollow metal door manufacturer simply creates a set of mounting tabs to attach the material to, and that's just simply how it's done. But the aluminum frame and the steel frame are put in the context of you need the receiver. That piece, again, will come with its own machine screws. Now, when you are going to install this unit, you need to remove the piece of equipment that is called holding fixture. And you remove the holding fixture by pulling out your clamping screws or fixture screws, of which there are part number 1, I guess fixing screws, that screw and that screw. Those get removed, and then the fixture will be then attached to the frame. And I have all of the screws here removed or loosened so that we can take the fixture out. One screw still attached. Okay, so all I've done is lifted this piece out, and now we have our fixture. This is what's going to get attached to the steel frame or the aluminum frame. You will, again, use the 2 screws here and here, here and here, total of 4. This gets fixed to the jamb. Then you will simply bring this and attach, your clamping screws and your height adjustment screws, clamping screws and height adjustment, back into the fixture that's been installed. This is the portion that will go towards the pull side of the opening. You can see that it's not prepped the same. This larger cutout, okay, is going to be towards the pull side of the opening. You'll note the door leaf has the same sort of large preparation and not so on the outside. So that larger, deeper cut will go towards the inside as well. Get that all placed back in there. Then we'll just simply tighten the screws. And then you're simply going to bring the unit installed, tighten the screws down, and you'll do that for all of your installations. And that is the same sort of process that you're going to deal with regardless of the frame type. Whether it be wood-based or it be metal-based or aluminum, will be the same. Page 4 of the installation instructions naturally get us to the adjustment that we have started this video with. Page 4 also talks about accessories in terms of templates that you can use to mortise for the material. You're going to need to mortise it one way or another. If you're doing multiple units, you probably will want to buy a template from the factory. You won't have to make one your own. You can obviously make one your own. The preparation for this is really not difficult. And now let's move on to a discussion of the overview of the Tectus system from the Hinge system brochure. Now there's another link below called the Hinge system brochure, and that's a great overview of the entire line. Really, the concept is the same between all of the different hinges. What causes the hinges to change is the weight of the door primarily. So they have the weight of the door and then also the design of the door, either an unrabbeted or a rabbeted door edge. Rabbeted door styles are a rabbeted door edge is another matter altogether, and you will certainly see rabbeted door edges in the United States. Generally not in new construction. You'll see it in older construction that's 19th century. However, in Europe, rabbeted door edges are common. I wouldn't go so far as to say the standard because I'm not an expert, but I can tell you that it's common. I've personally seen it. You'll also note if you take a cruise, those doors are rabbeted as well. Those boats are built in Europe. So that's where that comes from. So the index of the page allows you to take a look at the different, 15 different versions of this hinge, variations of it. Rabbeted, unrabbeted. Door weights are going to change. Then accessories, fixing plates, receivers, things of that nature. According to the manufacturer, their appeal is that they are basically making the hinge invisible. That is incredibly attractive to a lot of people when they're building doors and frames because they don't want to see the hardware. That's where you're going to see center hung pivots, and you're going to see edge poles. You're going to see hardware that doesn't detract from what it is that you're building. An application where you have a pair of doors that might be intended to blend in and to be as unidentifiable as possible is where a hinge like this is going to certainly come into play. And the fact that they are able to give you features in a concealed fashion does indeed make them a very desirable sort of option for a lot of designers. Features are quite frankly listed at it's completely concealed. They will create a flush condition, meaning if you stand on the pull side of the door and frame and you run your hand over the door and frame, the door is typically inset a little bit, 3/32 of an inch, some small amount. Well, you can create a flush installation where the face of the door and the face of the jamb or the wall, however it's being built, is flush and basically seamless. These hinges can handle up to 300 kilograms. Exceptionally heavy doors, 2.2 pounds per kilogram, so well over 600 pounds. That 3D adjustment, your height, your lateral adjustment, and then your side-to-side adjustment will swing up to 180 degrees. We're going to talk about that. For rabbeted, for square edge and rabbeted doors, wood frames, steel frames, aluminum frames, maintenance-free slide bearing technology. That's going to be a reference to between the knuckles. Now, one downside that is not commonly known, and it's probably not common because people don't really get into it or get that deep into it, I suppose. If you'll just focus on that pin, that hinge pin, door's in the closed position. I'm going to open the door to 90 degrees. I'm going to open the door to 180 degrees. What I'm attempting to illustrate to you, if you focus on the hinge pin, in your mind's eye, imagine a plumb line and a standard butt hinge or a pivot. That plumb line is the vertical axis of pivoting. It doesn't move. You can run an imaginary line through the center of the top pivot all the way through the door, through the bottom spindle, down into the earth. Hinges are the same thing. That vertical axis of pivoting doesn't move. As you open the Tectus style hinge door equipped installation, that vertical axis of pivoting moves a little bit. It goes on an arc. What does that mean? Nothing. Don't worry about it. Nothing to worry about. Unless you have overhead stops. Very common to have overhead stops with concealed hardware because not only do they want to conceal the way that the door is hung, but they need to control the door. If you're going to be hanging an epic 600-pound door on Tectus hinges, you probably want to have well, that's an extreme example, but if you're hanging a heavy door that will be 200 pounds and it is an application that's going to get used all the time, you will likely have an overhead stop, holder, something like that. When you are ordering your overhead stops and holders, you need to declare that you are hanging it with Tectus hinges because the template that will be included with the hardware will be based on the method of mounting. Also, it costs more money in general because that's called a special template, special templating. That has to be taken into account. So be sure if you're ordering this with overhead stops to account for that. Declare that when you're ordering your hardware so that the templating can come out correct. You would not, somewhere in the past, someone has done this and they've told me that the door doesn't swing smoothly through the entire opening arc, and it was ultimately discovered that the templating they used did not account for that small floating vertical axis of pivoting. Okay, so be mindful of that. Each of the system brochure talks again about the very substantial weights that they can handle, 180 degree opening, then a number of finishes. You are only going to see the hinge, of course, when the door is open. You're not going to see anything else, but when the door is open, you will see the edge of the hinge in the door and the frame, and they can accommodate those requests for different finishes. Continuing to move through the system brochure, they talk about their Tectus Energy. I have not used power transfer Tectus hinges because the one or two times that it was encountered, the hinge itself could not be manufactured to equip to handle the high inrush. It was an exceptionally high inrush product by Cowanir, maybe an older version of a Von Duprin device. I forget. I think it was the Cowanir, and it required about 16 amps of inrush that the Tectus could not handle, and we had to convert the power transfer to an auxiliary piece of equipment to handle that high inrush application. Moving through page 8, modern versions for special applications. They do have their FVZ series that are going to allow you to handle a design where the frame part is offset to the door part or sash part, and to successfully integrate a concealed hinge into these unusual applications where you need to have your flush condition door and frame where it's anything but that. So they've got hinges for that. They can help you with intumescence, meaning in today's day and age with fire ratings and the application of intumescence, Tectus has a solution for that if you're opening calls for intumescence. The ability to account for thick cladding on a hinge. Rabbited doors, they can account for that as I scroll through. Now let's move, you're going to get into seeing the different hinges in relationship to each other. And what you're really starting with is, how heavy is my door? And a conversation of how heavy is my door is where we're going to move to now. There's another document that's called Load Spec Guide. And as we scroll down to the TE540 3D, which is on the second page of the document that I'm currently looking at, you're dealing with the x-axis of your door width expressed in millimeters and inches. Then you're dealing with your door height expressed as the same. The table itself is weight in kilograms and weight in pounds. Okay, so you can see from the colored shaded area where the safe values are coming in when it comes to combinations of width and height. What we're saying is the orange value is where you are working in the area below the maximum rated weight for the material. So what they're saying is, this is based on 2 hinges on a door. They're also telling you, follow your manufacturer's guidelines in terms of quantity of hinges. If you're dealing with a 3070 door, it's 2 hinges for up to 60 inch. Add another hinge. The way that the definition goes is up to 60 inch. You've got 2 hinges. After that, add a third hinge. And then add another one every 30 inches after that. So the bottom line is, at 60 inch, you've got 2 hinges. You're at 61 inch, go with 3 hinges. Up to 90 inch, because that's 30 inch more. After that, add another hinge. That's standard guidelines. So the manufacturer's telling you, follow the guideline according to your manufacturer. You don't want to run a skew of what your manufacturer says. The bottom line is, if you're doing 3090 wood doors on Tectus hinges, the formula is going to tell you to have 4 hinges on that door, because we're 108 inch nominally on a 9-foot door. We are past 90 inch, but we're below 120 inch, so you're going to have 4. 2 to 60, 3 to 90, 4 after 120. The bottom line is, that door is only going to be, let's say, 150 pounds. Well, let's say it's 190 pounds. The truth of the matter is, you're well within the range of what your hinge can handle weight-wise. And you're really, with 2 hinges, not going to exceed the hinge's capacity weight-wise, but your door manufacturer is going to tell you, you need 4 hinges. And that's because if therethere's any warp in the door, those hinges are going to help keep that door together. And if you only installed it, I have customers that will say, 4.0, 7'6", that door is 250 pounds. The Tectus hinge we're using is a TE640, 2 hinges. And I say, stop. I know those hinges are really expensive, but that's not the door recommendation of the door manufacturer. 4076, 90 inch. 3 hinges are what's recommended. However, you get bigger than 3 foot, now you need to start thinking about, I need bigger hinges, I need more hinges. So I recommended 4 hinges, not because I'm a hinge salesman, but that's what my training tells me to use. And the client went from 2 to having 4 recommended. And these hinges are $400 each, to 3. And in fact, I'm coincidentally going to be close to that job site next week in New York, and I'm going to be inspecting the integrity of that opening to see how that all looks. Very busy hinge jam. Same job where we need it. We couldn't use the Tectus energy hinge. We had to go with the auxiliary hinge transfer. So the positioning of the hinges is also based on 10 inch from the top and 10 inch to the bottom, to the center line of each hinge. That's what they're thinking about in terms of how this table was derived. The reference load carrying capacity is based on a height to width ratio of 2 to 1. For example, assuming a reference value for a door leaf dimensions, they're basically saying, for a 1,000 millimeter wide door, we're talking about a 2,000 millimeter tall door, or, roughly 40-inch wide by 6'8" tall. Required number of hinges, refer to your manufacturer. Lots of tables there for all of the hinges. You'll want to refer to that when you're dealing with, how do I specify this hinge? Tectus is new to me. What do I do? How do I proceed? Which hinge do I use? Because if you're new to it, they've got a lot of part numbers that are basically making us look at the information and saying, none of this makes sense. I don't understand how these part numbers work, but this catalog helps dispel that. Now, what you'll notice, after you've selected the hinge based on weight rating, you'll get to where you see their placement of their hinges. So North American manufacturers are going to be dealing with like 5, 10, and equal, which basically says, and that's not the only way to do it, it's just the easiest way for the following analogy to roll off the tongue. Top of the door, underside of the header to the top of the first hinge is 5 inches. Bottom of the frame to the bottom of that hinge is 10 inches. And then make them all equal moving down. The nice thing about that is they don't really care about the height of the door because we have a formula. It's always this at the top, it's always this at the bottom. Space out every other hinge accordingly, evenly, equally, following the 2 hinges up to 60 inch, 3 hinges up to 90 inch, 4 hinges up to 108, meaning another hinge for every 30 inch. However, if you're in Europe, you are always going to see, and back to our cruise boat analogy, you're always going to see 2 hinges at the top, 1 hinge at the bottom. Turns out that's really smart to do it that way, even though we don't at all do it here in the United States. And it ought to be adopted, and here's why. The engineer for a major hinge manufacturer has stated that the top hinge is responsible for carrying 70% of the weight of the door. So back to our example of a 290-pound door or whatever it was, that top hinge is carrying 70% of that weight. That hinge itself, when you talk about my client who wanted to use 2 hinges, wouldn't go to 4, but begrudgingly went to 3, that's bad math because that top hinge is doing an inordinate amount of load, of work, carrying the load. And that's why when you are dealing with this heavier material, you need to think about, I need more hinges, or I need to change my thinking about where I'm going to place those hinges. I would have advised in these exceptionally heavy doors, get 2 at the top, maybe then 1 at the bottom, and then maybe a 4th hinge is where you're going to want to do that. Obviously, these hinges are tested. Obviously, these hinges has been found to be compliant with the weight rating that they've put forward. At the end of the day, for me personally, it boils down to screws acting against each other. Obviously, all of this is meant to handle the weight. But at the end of the day, I've got a lot of ability here to adjust that I don't want to tax fasteners when it is intended to keep the door and frame where it is. Again, I've not heard of people saying that the hinge failed because of the screw fastening system, so it must work. Do consider an unorthodox approach to location of the top 2 hinges if your weight requires it. You can see that the manufacturer gives an example of 2 hinges for 8-foot doors. When it's less than 8-foot doors, we're going to stick with our definitions as they apply to the door manufacturer. Here's what I'm trying to say. Unless your door manufacturer will give you a warranty on the location of these hinges and the quantity of hinges that you're using Tectus hinges, then conform to whatever the door manufacturer is telling you they require. Because any trouble with the door, any trouble at all, that causes a warranty claim, it will be disallowed because the hat that they will hang, the hook that they'll hang their hat on is the door is improperly hung. Follow that only if you are expressly with the understanding that it's compliant with what your door manufacturer calls out. And that exhausts the entire load portion of the hinge. We're going to next take a look at, we'll breeze through the what they call data sheet. It's really a cut sheet. Then we're going to get into the fitting instructions and then bring this in for a landing. Now, the one-page document regarding the, well, actually, it's a four-page document regarding the data sheet is a great overview of the hinge itself. We won't touch on all of it, except let's talk about, we talked about adjustment. This TE540 3D hinge, completely concealed for flush doors with wood, steel, or aluminum frames. It's UL listed for 20 minutes with a user-friendly three-way adjustment. Load capacity is up to 120 kilogram. Opening angle up to 180 degree. Gives us the overall length. Non-handed, maintenance-free slide bearings, 3D dimensional. The side is plus or minus 3 millimeter. This is the point. The side is plus or minus 3 millimeter. The height is plus or minus 3 millimeter. And then the compression is plus or minus 1 millimeter. That's the in and out portion. Sure seemed like it was a little more than 1 millimeter when I operated it. Minimum door thickness is 1 5/8. For fire-rated doors, check the door manufacturer regarding the usage of additional required intumescent material. What that means is the listings that your wood door manufacturer has will be dependent on the hardware that's being put on it. So the question you'll want to make sure, well, if you issue machining sheets in a purchase order to your wood door manufacturer and you list Tectus, they will let you know if there's anything that they require to be able to properly label that door. And it's possible that you'll need intumescent options for that. Certainly before you get to the point of sending a purchase order and machining sheets, it will be discovered what's going to be ultimately required. Square corner plates are available upon request. You can order square on these if you wanted to for aesthetic reasons, I suppose, alone. Back to the load capacity, it would be reduced by 20% if you're using a door closer. A door closer obviously puts a lot of downward angled force and pressure on the hinges themselves. They would certainly aggravate the health of the hinge in a long-term perspective. So be mindful of that. Okay, now moving to page 2, they talk about the router bit and a part number for that. 24 millimeter router bit. They also have a 3/4 inch router bit with a 1 inch collar ring. They get into the different finishes that are listed there. Suffice it to say there's at least a dozen finishes, and all the common finishes: polished brass, polished nickel, traffic white, powder coated, and that's where you can get into lots of different possibilities. This project was initially requested as a powder coat finish, and when it was determined that the cost and lead time for a powder coat, given the fact that this was in essence compatible with what they were doing, the client chose for the 175, which would give them the bronze finish light. You can see it's not obvious, but the item number that they have, if we're looking at polished brass, it's going to be 030. Second from the bottom is bronze finish light 175. 175 is the code for this color. Powder coated, they can do a matte black, satin chrome look, satin nickel look, satin stainless steel look, satin nickel, satin chrome, rustic umber, bronze metallic, bronze finish light, bronze finish dark. So 15 finishes, well, 14 before you get into the powder coat possibilities. Page 3 shows a nice simple cross section of a block frame installation. You can certainly imagine that that would fit for a hollow metal installation and maybe even an aluminum frame installation. And that's where the data sheet ends up. We can then move to the milling template, and let's go with a casing frame or a block frame that comes back the same way, really. We'll look at the block frame. It's probably a little bit easier, I suppose, to view in a cross section. So the bottom line is the preparation for this hinge is indeed going to be dreadfully easy. Maybe not to everyone, but the bottom line is it just simply is. Why a 24 millimeter diameter router bit that you have to buy special? Well, it's because it's going to give you a really nice radius with what you're doing. It's going to give you a nice radius with what you're doing with the preparations that are required. Okay, so what the manufacturer is looking for here is two preparations. And the drawing is unfortunately it has, as far as I'm concerned, it has a couple of stray lines in it. I would put this into terms of doing a body preparation and then a plate preparation. The body preparation is going to be the 157 millimeter dimension from here down to here. Okay, that's going to have a width of 32 millimeter. So you're going to do a preparation at the proper center line, 157 millimeter long, tall, 32 millimeter wide. Okay. At that point, you will then do a plate preparation only up in this area here that will be an overall height of 200 millimeter, thickness of 10 millimeter. So you're going to, and still 32 millimeter wide. So you're going to come over 200 minus 157 divided by 2, 43, 21.5 millimeter up, 10 millimeter deep only. That is then going to allow that entire hinge to sit in place. You can sure do, I guess, 3 preparations if you wanted to just do a body prep down here, radius this to only the 30 to only the yeah, well, you'd have to measure that with your caliper. If you wanted to two-step that around that profile, that's not the way the template's calling it out, but I suppose you could. That might serve to make it fit a bit tighter in the opening, but at the same time, I don't think that's really going to be a concern. So you'll have your body prep, your body prep, then your plate prep, and then you're going to have that completely in alignment. Now, the only area where you've got some math that you need to do is in the center where they're showing what is the backside of the hinge supposed to be, and backside is this is being measured on the face of the door rather than on the push side. It's being measured on the pull side. So the A dimension is the face of the frame up to the seal. Maybe that's going to be the face of your stop. Okay, probably the face of your stop. That's your A dimension. Your B dimension is the door thickness. Your X dimension is going to be it's your rabbet is really what it is. If there's weather stripping, you're going to consider that the face of the stop. Your rabbet, less your door thickness, is going to, plus 4 is going to be your X dimension. So the bottom line is, your X dimension is going to be 4 millimeter, 5 millimeter, or 6 millimeter. Okay? You're either going to have 4 millimeter where it's flush, okay, or the door is going to be inset 1 or 2 millimeter. That's all. It's going to be either flush or inset up to 2 millimeter or any increment between the two. You have a vertical center line established on this hinge. That is understood expressly as the center of the thickness of the door. And that's why that formula A minus B, taking the X value, is going to put the door and frame into relationship with each other. And hopping over to look at the steel frame information is helpful because it shows you the minimum size that you require to install the material, but it's showing you the receiver, the TE540 3DSZ, that receiver that they want to sell you, which you should probably want to buy. It will make life easier to get the item installed. What minimum dimensions that you're going to require to fit it physically into the frame. This job that I've referred to a couple of times, we had an unusual face dimension, and it was but just barely exceeding the minimum amount required for the installation. It worked fine, it worked perfectly, but you have to be mindful of what your minimum requirements are. Dealing with heavier doors, you're dealing with bigger hinges. So if you try to run a 1-inch face on a 14 gauge hollow metal frame and toss and have a 290-pound door, you're going to need more room, is the bottom line. That's why that template is there. Now, looking at the rest of the available documents that we have, there's finally a UL listing certification document. And the reason that you might want to have that available to you is because hardware that's used on fire doors must be at least listed, meaning there is on file at the testing laboratory, in this case UL, a document that says, yep, we tested that hinge, it's compliant. And it can be labeled as well. This hinge does have visual evidence right at the tip of my finger, all the way in the back, as the UL mark. And your inspector with a small little flashlight can get in there and see that. Fire door assembly inspections are mandatory per code in 4 occupancies. That will continue to expand. Inspectors looking for that you have hardware installed in accordance with the fire rating of the opening is at a minimum going to need, upon demand or request, that document, and ideally they're looking for visual evidence of it, even though typical ball bearing 5-knuckle hinges don't have to have visual evidence. They don't have to be labeled, but they're certainly listed. But that is an exception to the rule. Hardware in general needs to be labeled so that the inspector can visually determine that it is in compliance with the requirements of a fire-rated opening. The other documents there to look at, we've talked about everything. I'm a fan of the hinge. I like the adjustability. I'm not sure that I might make a purchase decision based on solely having it. There is a cost upcharge to having that ability, but a lot of people like the adjustable hinges, and I know of installers who will order it exclusively because of the adjustability, and I'm not sure if that's compensating for maybe not being able to absolutely machine the material where it must be machined. So I've provided the evidence by which you can make a decision. Any questions on the Tectus? This is their part number TE540, 3D hinge and a 175 finish, light bronze light, or any other Tectus product. Please feel free to reach out to us. And thank you.